Right, continuing section 13.1, we're looking at graphs in real life situations. This is question 6, a different type of graph. We've got a chap called Abraham. He's filling up his bath with water, presumably to take a bath. The sketch graph shows how the volume of water in the bath changes. So what have we got? Essentially we've got water going into the bath, so it's filling up, then more's going in, but not as fast. Anyway, so let's just take it one question at a time and let's explain. Which part of the graph shows when the bath was filling up at its fastest? Right, if it's at its fastest, we're going to increase volume in less time. So we're looking for the steepest part of the curve, or rather steepest part of the graph. So I think from O to A, it's steeper than A to B, so this will be fastest. And why? Because steepest part of the graph. Alright, so I'm just going to squeeze it in there. I might write down here in the black bit if I run out of space. Right, so that's that. How can you tell it's the steepest part of the graph? What do you think may have happened at A? Well, I reckon water's going from O to A, maybe 1 or 2 taps, but you've got 2 answers there, and I think we'll do it down here because it'll stand out better. So this is part B. What do you think is happening at A? 2 ways of saying. One of the taps could have been turned off. Fair enough. If you imagine hot and cold going in between O and A, if one of the taps has been turned off, it will fill up less quickly, won't it? Could have been turned off. Or, here's a second answer, both taps could have been turned lower. In other words, the water wasn't coming out so fast. The water was therefore, it's really hard to write this, was therefore flowing out of the taps at a slower rate. Right, so you turn the taps down, as we say in common speech. Taps being turned lower, the water was therefore flowing out at a slower rate. Right, C. What happened at B? I reckon both taps were switched off, or we can say both taps were off, or we can say no more water was being added to the bath. Question D. Here's a strange question. So this guy decides to clean the bath as the bath was emptying. Which part of the graph shows this, and how can you tell? Well, look at this. I will point to this part. Here, the bath is definitely emptying because we're going from a higher volume in C to a low volume in D. Emptying. It's also emptying between F and E. It looks as though he put the plug back in between D and E because water was not running out of the bath anymore, neither was it filling up. The graph is not going up but staying flat. So what have we got here? The water's emptying out of the bath, then he puts the plug hole back in, perhaps cleans the bath at that point, then empties the plug hole, then opens the plug hole, and then lets the remaining water come out at the rate that you see there. So it's quite hard to answer it. Which part of the graph shows this? Well, it could have been cleaning between C and D as it was emptying. It could have been cleaning between E and F as it was emptying. And I don't know what he's doing in between D and E. The only sensible suggestion is going to be is he's put the plug back in the hole to stop water running out. So loads of different answers would actually do here. While it's being emptied, okay, while it's being emptied, okay, the bath is being emptied between C and D and between E and F. Let's see if I answered it correctly. Clean the bath. Which part of the graph shows this? Okay, so the bath is being emptied between C and D and between E and F. That's when he's doing the cleaning. That's essentially it. Won't go any further than that. Right, this is Sharon. This is question 7. Different style of real life graph. A real life graph nonetheless. It says Sharon has a mobile phone. If I just follow it like that, mobile phone. The only charges she pays are for her calls. The graph shows her monthly charges for calls up to 300 minutes. Well, there's your 300 minutes. There's 0 minutes, and there's 0 to £30. Right, what is her basic monthly charge? As you can see, the basic monthly charge has got to be £15, and she has to pay that £15 flat rate for the first 150 minutes. So what is her basic monthly charge? If I write it here in blue, so I've got here £15, and I showed you where that was here, right there on the axis where the charge is expressed. B. How many minutes are included in Sharon's basic monthly charge? Well look, we have a flat rate of £15 and we go up to 150 minutes, so let's just show the examiner what we're doing. So right there, that's where the graph suddenly goes up, and again, remember that we show the examiner what our brain's doing, and we put a little arrow going down. So there we are. So how many minutes are included in Sharon's basic monthly charge? We have 150 minutes. Next question, C. How much does Sharon pay for her calls? Sorry, how much does Sharon pay per minute for her other calls? Well, let's just take a look. I've gone from 150 to 130. Is that correct? Yes. 150 to 130. So I've got the remaining 150 minutes. And what does that cost? Well, from 15 to £30, that's an extra £15, isn't it? So that's for £15. How much per minute? So let's do a little sum down here in white where it stands out. I've got £15 shared amongst 150 minutes. So let's just be sensible. We've got 1500 pence, 150 minutes. So let's just lose a couple of these. Well, 15 goes into 150 10 times. So therefore, it'll be 10p per minute. Is that right? So we're dividing by minutes now, and we're dividing by pence by minute. So 10p per minute is the rate that